All right, so we're gonna continue discussing the topics from the last session. So we discussed until uh, realistic movement with Unity's physics systems. That's the last topic we discussed. So next topic is physics-based movement in Unity. So let's break down the topics and the code step by step. Uh, So in Unity, the rigid body component is what brings a game object into the realm of physics. Adding a rigid body to an object makes it subject to forces such as gravity, allows it to interact with other objects in a physically accurate manner. So this is crucial for creating lifelike interaction. So we have a direct and physics based movement. So uh, direct is basically uh, you're directly modifying a game object's transform component to move or rotate it. So this approach bypasses the physics engine to calculate the bypasses the physics engine, leading to an unrealistic movement that don't respect physics laws like inertia or friction. Whereas physics-based movement, it uses the rigid body component to apply forces and or set velocities, which allows Unity's physics engine to calculate the resulting movement. So this method creates more natural and realistic interactions. uh, Let me open the code here. Yeah, so this code uh, demonstrate how to access and store a reference to the rigid body component attached to the player game object. So we declared a private rigid body RB. This line declares a private variable RB of type rigid body. This variable is used to store the reference to the rigid body component attached to the player object, enabling us to interact with it programmatically. And in the start method, we have so the start method is the Unity's lifecycle method called when the script is first initialized. So inside this method, we have a get component rigid body is called to find the rigid body component attached to the same game object the script is attached to, and stores its reference in the RB variable. So if the rigid body component is not found, get component rigid body returns null. However, since we are sure a rigid body is attached to our player, we don't perform null checking in this code. And yeah, from the last I mean we discussed about direct transform manipulation. So I have already, I think that code is not in here, but usually if you're following the textbook, you'll have the transform manipulation code. Comment it, because uh, let me actually show you how that's gonna look. Yeah, so these lines of code now should be commented out, which are responsible for directly manipulating the physics position, player's position and rotation using the transform component. So this approach is being phased out in favor of the physics-based movement. So the decision to comment these lines out is the preparation step for replacing them with physics-based movement commands in the subsequent sections. So now yeah, we are transitioning to the physics based movement. So by storing a reference to the rigid body component, we are prepared we have prepared the groundwork for moving the player using physics. So in the upcoming changes, you'll use methods like rb dot move position, rb dot move rotation for movement and rotation, or apply forces using rb dot add force to more uh, for more dynamic movements like jumping or dashing. So these methods respect the physics engine's calculations, resulting in more realistic behaviors. So the key takeaways is rigid body is essential for physics-based interactions in Unity, allowing the game objects to move and interact in a realistic manner. And transitioning to physics-based movement enhances realism and also adheres to the principles of physics, providing a better gameplay experience. And then accessing and storing the rigid body component is another important first step in implementing physics-based movement. So this enables physics script-based control over the game's objects physical properties and behaviors. um, Actually, let's discuss about colliders first. So I'll give you an introduction about colliders. Basically, colliders in Unity are the components that define the shape of an object for the purpose of physical collisions. So they basically act as a invisible force fields around the game objects, determining how these objects interact with each other and the game environment. So the purpose of the colliders is the primary role of the colliders is to enable Unity to detect when game objects come into contact or collide, to manage how these objects respond to such interactions. So there are different types of colliders. uh, Unity offers several types of colliders, including box, sphere, capsule, mesh colliders. So each type matches different object shapes or more accurate physical simulations. So there are components, collider components. So the shape of the collider can be configured to match the object it surrounds. For example, a capsule collider is often used for characters because its shape closely resembles the human form. And colliders have properties such as center, radius. For sphere and capsule colliders, its radius and height. For capsule colliders, that can be adjusted to fit the game object's shape accurately. And we have a physics system. So physics system basically, uh, its Unity has distinct physics systems for 2D and 3D games, each with its own set of components. For example, uh, rigid body versus rigid body 2D, collider versus collider 2D. So uh, this discussion basically focus on 3D game development. So for collider to interact with Unity's physics engine, like gravity or friction, it often works in conjunction with a rigid body component, and the rigid body adds mass to the object and allows it to react to forces and collisions in physically accurate manner. And so there are also collision messages. So collision messages are basically when colliders come into contact, Unity sends out messages such as on collision enter, on collision stay, or on collision exit. uh, Scripts can listen for these messages to trigger specific behaviors like collecting an item, taking damage. And colliders can be set as triggers to detect when objects enter, stay, or exit an area without physically blocking them. So this is useful for creating areas that trigger certain actions like entering a dangerous zone, so without actually affecting the object's movement. A common use of colliders is to detect when a player collects an item by attaching a collider to the item and setting it as a trigger. You can create a script that responds when the player's collider enters the trigger area, simulating item collection. So some of the best practices is you always choose the collider shape that best fits your game object's form for optimal performance and accuracy in collision detection. and use the scene view to visually inspect and uh, adjust colliders. So Unity shows colliders with green outline when selected, allowing you to fine tune their size and position. So understanding understanding and effectively using colliders and collisions is important for creating interactive and physically realistic environments in Unity games. So by configuring colliders correctly and responding to collision messages, you can add a wide range of interactive elements to your games, from a simple item pickups to complex environmental interaction. Let's go to pickup mechanics. So now we'll see how to implement a item pickup functionality in Unity using a collision detection, especially by updating an object to respond to collisions through scripting. So this example will guide you through creating a script that enables a player to pick up an item like health boost by colliding with it in the game environment. The main goal is to give you a clear understanding of how collision detection works in Unity and how you can use it to make interactive game elements. So first, ensure your game object, for example a health pickup, has a collider component. So this is crucial because collision detection in Unity relies on colliders. And then you create a new script called uh, item behavior. I've already created a health pickup item behavior. So, and attach this script to the health pickup object. So this step is important because the collision detection logic is will reside in this script. So the script's purpose is to detect when a player character collides with the item and then perform actions like picking up the item. And in Unity, on collision enter and on collision enter yeah so on collision enter collision method is automatically called when the collider of the game object the script is attached to collides with another collider. So the collision parameter here uh, contains information about the collision, including a reference to the collider that was hit. And so basically on collision enter is triggered by Unity when the collision occurs, and the collision object contains all relevant data with about the collision event. And the collision check, we check if the colliding object is the player by comparing the name property of the collision dot game object to player. This is a simple way to identify the player, assuming the player game object is named player, and destroy. So if colliding object is indeed the player, destroy this dot transform dot parent dot game object is executed. So this line destroys the parent game object of the script, effectively removing the item or any of its children from the game. So it's important because item behavior might be attached to the child object of the actual item you want to remove. And feedback. So the debug.log item bagged or collected provides a console output for debugging purposes, indicating the item has been successfully picked up. So the difference between collision and triggerer is this example uses collision detection to initiate item pickup. Unity differentiates between collisions. Collisions are basically physical interactions where objects can't pass through each other, and triggerers is where objects can pass through but still detect the interaction. So this script uses the former to detect when the player physically collides with the item. And the script assumes a specific hierarchy. When the item behavior script, the script is attached to the child object of the item to be picked up. This structure allows the use of this dot transform dot parent dot game object to reference and destroy the entire item, the game object upon pickup. So This basic example can be expanded or customized. For example, instead of checking for the game object's name, you could use tags, layers, or interfaces to make the collision detection more robust or adaptable to different items or player characters. So this with this example, you will learn the fundamentals of collision detection in Unity, and script attachment and hierarchy importance, and practical script writing for game development. So yeah, this knowledge forms the foundation for creating interactive and dynamic game worlds where objects can interact with the player and each other in meaningful ways. Let's go back. So now let's go back to again collider triggers and implementing enemy behavior in Unity. So Unity collider components are important for detecting interactions within the game. So by toggling a collider's each trigger property, you create a non-solid trigger zone that invokes specific events without physically blocking game objects. So this feature is instrumental in game mechanics where you need to detect if a player enters a specific area, like enemy's detection range, without causing a collision. So let's understand the collider triggers. So colliders can be visualized as invisible boundaries that define the physical shape of an object for collision detection. So Unity provides collider shapes, box, sphere, mesh, etc., which are suitable for different use cases. And when it comes to trigger property, so when the each trigger property is enabled, the collider becomes a trigger zone. Instead of stopping the game objects, it allows them to pass through, enabling the game object to send and receive special events like on trigger enter or on trigger exit. So the process of creating an enemy that reacts to the player entering its detection zone involves setting up a trigger collider and scripting the response to trigger events. So first you set up the enemy game object. You add a capsule game object, named it as enemy to represent the enemy, and attach a spear collider to it, and enable the each trigger property, and also adjust the radius to define the detection range. And I don't think we have an enemy behavior script here. Yeah, let me open a notepad. So give me 1 second. So uh, we basically create a enemy behavior script. So we have a on trigger method, on trigger enter method. So then that method is invoked when another collider enters the trigger zone, and use it to detect the player's entry. So we also have a on trigger exit. Let me take that code. Yeah. So this is your on trigger enter and on trigger exit. So on trigger exit, this method triggered when a collider exits the trigger zone, signaling the player has moved out of the enemy's detection radius. Uh, so the backbone of Unity's physics is rigid body components. Basically game objects with real world physics behavior, allowing them to uh, interact with forces, gravity, and other objects in a physically accurate manner. And we have a collider components, which are basically essential for defining the physical shape of the objects for collision detection and physical interactions within the game world. And colliders can either block or allow passage through them, determined by their configuration. We have solid colliders and trigger colliders. By default, collider components block other objects, acting as solid barriers, which are solid colliders. And when it comes to trigger colliders, when set as triggers, the ease trigger property is checked. The colliders allow objects to pass through, enabling the detection of entry, stay, and exit events without physically stopping the objects. And we have kinematic, non-kinematic objects. So kinematic objects with rigid body components marked as is kinematic are moved explicitly through code without being influenced by Unity's physics engine, like no gravity or collisions. Non-kinematic objects, these objects are influenced by forces, gravity, and collisions within the Unity's physics system. Movement and rotation are typically achieved through applied forces or torques for more dynamic and realistic interaction. And we have collision notifications. Unity's physics system broadcast notifications during various stages of interaction between collider components. So collisions, when solid objects collide, Unity triggers specific methods like on collision enter, on collision stay, on collision exit. And when it comes to triggers, for trigger colliders, corresponding methods are like on trigger enter, on trigger stay, and on trigger exit are called, allowing for custom behaviors when objects enter, remain within, or exit the trigger zone. So this chapter has laid the foundation uh, for creating dynamic and interactive gameplay in Unity. Your It took you through the essentials of game mechanics, starting with basic movement and progressing through more complex interactions, which are using the Unity's physics system. So we discussed about vectors and movements. You learned, we discussed to manipulate how to manipulate a object's position and rotation using vectors, which is crucial for understanding movement in within a 3D space. So by understanding vectors, you'll know how to navigate a character through a virtual world, providing a smooth and intuitive gameplay experience. And we discussed about player input management, like handling player inputs effectively is vital for creating responsive responsive gameplay. We explored how Unity's input class allows for easy capture of keyboard actions, enabling you to map player commands to character movements seamlessly. We discussed about camera dynamics. So implementing a following camera has demonstrated how to keep the player at the center of the action, enhancing the gaming experience by ensuring the camera perspective always complements the gameplay. And Unity's physics system, we we discussed about Unity's physics system that has uh, showed the power of rigid body and collision components. So by understanding these elements, you'll learn to create realistic interactions within the game, from basic collisions to complex physics behaviors. And we discussed about event-driven interactions. So the use of colliders and triggerers has introduced us to event-driven programming within Unity. So this concept is essential for triggering game events such as collecting items or activating enemy behaviors based on players' actions and interactions with the game environment. Prefabs, converting game objects into prefab has not only streamlined your game development process but also may highlighted the importance of reusability and efficiency in game design. Prefabs allow for easy modifications and can be used across multiple scenes, making them a fundamental aspect of Unity's game development. So this topic has equipped us with the tools and knowledge to start building more complex game mechanics. As we move forward, remember that experimentation and practice are key to understanding Unity's capabilities. So the upcoming topic will build upon these foundations, introducing you advanced mechanics like jumping, dashing, and shooting, further expanding your our game development skills. So that's the end of this topic. Thank you.